All right, thank you guys for coming. I really appreciate you guys taking the time out of your day to be here. Sorry we got started a little late there, just trying to make sure everyone get a chance to come in and get settled. We're sorting that out right now. The food will be here soon. So sorry there's no food yet, but we will take a break at some point too, so you guys can grab some food. My name is Kevin Jones. I'm a developer relations engineer working at Edge and Node, working on the graph. Also very active in the Scaffold-ETH community in what's called the Build Guild. I'm going to be talking a little bit about that as well today. And the goal is today to teach you guys kind of the full stack, like how you actually build a dApp. Specifically, we're going to be talking about Ethereum, and we're going to utilize Scaffold-ETH 2, which is the newest version of Scaffold-ETH and the graph to do this. I want to kind of preface the talk with, okay, by the way, this is open source, the curriculum and the steps that you're going to need to follow. I would say the workshop probably is more of like a 2-hour, maybe even more workshop. So we're going to get as far as we can in it, but all of the steps are outlined in the workshop. I literally just wrote this, so I know that they're pretty solid. You guys can scan this, or you can just go to bit.ly/fullstackdApp, and that will take you to the repository. If you want to follow along, you need nodeJS installed. You also need Yarn Package Manager because we're going to set up a Yarn package. You also need Git, obviously, to be able to check out the repository for the project. And then you'll need Docker if you want to follow along for the graph stuff, because we're going to actually run everything in Docker, which is really cool. So everything can be run locally. That's the goal, is to show you how you can deploy an app locally and then eventually actually publish that to a blockchain, to a testnet or to mainnet. I do want to kind of preface the talk and talk a little bit about talk a little bit about blockchains in general and a little bit about what we're building and why we're building it. So raise hands if you have some experience writing some kind of smart contract before, if you've written a smart contract. Cool. Raise your hand if you have some front-end development experience. Cool. That's a lot of times the disconnect that I see is we see like a lot of like developers that are like, oh, I can write smart contracts, and like they're specialized in that. And then we have like this front end community, which is like really been doing like Web 2 stuff, and they don't really understand the connect. And so really the goal of this is to teach you guys how they kind of come together. And then also talk about some of the problems that there is with the current architectures, or I should say the initial architectures of blockchain applications, and how you can fix those with the graph. So what is a smart contract? It's really just a state, a contract that keeps track of state. So you can literally think of it as something like an Excel sheet. This is an example of the CryptoPunks NFT, where we can see that there is a particular data structure that keeps track of the IDs of the NFTs, who the owner currently is, and then where that URI for the object sits for the actual NFT, like the image, right? Or where the metadata is stored. And it's really the business logic of a smart contract is to manage that state, right? And real quickly, if you want to make changes to the state of a smart contract, you need to initiate a transaction. And this is where you're trying to submit a transaction to the blockchain to update state or do some kind of function within the smart contract. But there's one problem when it comes to data, particularly on the blockchain. When you want to update your smart contract and stuff like that, the blockchains are usually incentivized on rights. So they're incentivized with rights. But the initial dApp architecture, when Ethereum first deployed smart contracts, was this concept where you would build your user interface in your front end in something like JavaScript, and you would deploy it in a way that was maybe like decentralized, like with IPFS. And then you would put your core business logic of your contract into a smart contract that sits on the blockchain. And then you would write and you would read directly from the blockchain or from the smart contract. But there are some issues with that. Again, the blockchains are usually incentivized for rights, right? It's a security-based consensus architecture where in order to make changes to the state, you need to sign something, provide some gas, pay some gas to be able to make that state change. But as far as reading goes, there's no incentivization for the blockchain, particularly to give you the data that you need in an easy way. It's not architected that way. It's really architected for rights. And so this also gets this problem of provenance. So provenance is this concept of like historical data. Like If you want to get the exact owner of a CryptoPunk at a certain time in the blockchain, that can be very difficult to do. You literally have to go through and find all the transactions for that particular NFT, and you kind of parse through those and get that data and loop through, and it can be very difficult to do if you're writing a dApp. And so the idea is that we want to create some kind of like time machine for our data, right? How can we get this in an easier way to understand without having to use the blockchain directly and calling the blockchain directly, or looking up the data we need by running our own node or something like that? And this is where we see this existing problem. Like, this is just some actual code that was running in the wild, where someone wanted to get all of the NFTs that a particular wallet owned, or a particular person that was using the dApp. And this is okay if the owner only has a few NFTs in their wallet. You can think of each call to the actual blockchain might take maybe 100 milliseconds or so. 300 milliseconds isn't bad, but the minute that the user starts to get large amounts of NFTs, you're literally having to sit there and wait, and the page load time could be upwards of seconds, 10 seconds, 20 seconds to load all of the user's NFTs by doing this method. And it's just not a pretty way as well. It's very difficult to read, and it's very difficult to write. And so this is where the graph comes in. And the graph is, you can think of it as a decentralized data layer for a blockchain, right? For all blockchain data. The graph currently serves anywhere between 1 to 2 billion queries per day, which is pretty substantial, I would say, in the realm of applications. And that's constantly growing as well as the more dApps come onto the network. The graph is serving this data. And so what is the graph? The graph is an indexing protocol. You can almost think of it as kind of like this middleware, middle layer that kind of sits in between the user interface and the actual blockchain applications that you're running in your smart contract. And it's indexing all that data and making it available in an easy to consume way using GraphQL. So using a GraphQL API. And it's customizable. So you can create subgraphs for different data that you care about in your smart contract. There's also a lot of smart contract subgraphs that are already created. So like, let's say you want to get Uniswap data, there's already a subgraph for that. You can go to the Subgraph Studio and you can get the data for Uniswap easily by just querying that subgraph. So that's all the slides I have today, because this is a workshop, and the idea is that we want to actually show. I'm a big fan of like showing how you do something. So if you don't already have this and you do want to follow along, bit.ly/fullstackdApp will do that, or you can scan this. Does anyone need a second to do that? All good? Awesome. Okay. So let's kind of get started. So the base of what I'm going to be showing off today is built around what's called Scaffold-ETH. So real quickly, essentially, when you're first getting started building dApps, it can be a little difficult to figure out what tooling you need, right? Like, okay, well, what do I need to be able to get read and write from the blockchain? What kind of front end should I write? What kind of blockchain should I use? Should I use Hardhat or Foundry? And so Scaffold-ETH 2, there's two versions of Scaffold-ETH. There's Scaffold-ETH 1, obviously. There's Scaffold-ETH 2. It's the newest version. There's a lot of kind of like choices that are made for you out of the box, but they're good choices. An example would be we use NextJS. We use RainbowKit. We use Hardhat. We use Wagmi. We use TypeScript. So we have a lot of like kind of industry ways that you would kind of create a dApp built into this tool. And so it really allows you to kind of get up and running quickly when you're trying to build a dApp. It's very useful for prototyping and building out your dApp. Then there's, on top of that, there's right now, the way it's set up is there's a separate package, or I should say branch, called Subgraph package right here. And this one has a full-blown example of how you can build out your dApp with Scaffold-ETH 2, but then also use the graph running in Docker. So that's what we're going to use today for the workshop. So if you guys need to, you can always go here, go to this branch, and you can grab it. Again, all the steps are going to be outlined in this, okay? So we're literally going to go through this through as far as we can. We will take a break at some point to give you guys a little bit of a reprieve. But let's kind of get started. Let's go ahead and load up. Can you guys see my screen back there? Is it easy to read? You need me to make it a little bigger? A little bigger? How's that? So I'm using tmux, which is like a terminal multiplexer. It just allows you to have multiple windows. Everything you do with Scaffold-ETH, you kind of do in a lot of windows, and that's because you have your backbone running in your smart contracts running in Hardhat. You have your front end running in React with NextJS, and then you have this kind of like Docker container that's running all of your Docker containers for the graph, and then you have this kind of like fourth window where you're doing your deploys, and there's a command line interface. Everything in Scaffold-ETH is built around this concept of using Yarn scripts. If you're not familiar, Yarn is a package manager that allows you to write scripts to do things kind of easily, so you don't have to memorize the whole commands. And so it makes it really easy for you to get started. So I've gone ahead and I've already checked out the repository, so we can assume that the first step to actually go in and check out the repository branch and put it into this folder is already complete. But what that looks like is right here. We do a git clone, choose the subgraph package as the branch that we want, and then use the git file, and then we can name it whatever we want. I named it workshop. It doesn't really matter what you name it. And then the next step is to do this yarn install. So what that's going to do is it's going to reference the yarn package and decide what packages need to be installed. Okay, so if you just run yarn or yarn install, it's going to go out and check all those and grab those for you. That's it. You're pretty much good to go at this point. Everything's kind of set up. Yarn chain is going to bring up a copy of Hardhat running on localhost. And if you're not familiar with Hardhat, Hardhat is a virtualized kind of Ethereum virtual machine that you can run on your network, or run on your local network, so that you can simulate transactions to a blockchain. You can also like fork a blockchain. Like if you wanted to fork mainnet, you could do that with Hardhat as well. But we're just going to use this kind of like empty skeleton Hardhat instance, right, for everything we're going to do. It's also going to generate a bunch of accounts for you. So if you know blockchain applications, this concept of using cryptography, it comes with 20 accounts that have some play ETH in them so that we can start kind of toying around with that. So we're always going to leave this window open. Yarn chain, keep it running. I'm going to open up another window over here in the corner, and now we're going to start up our front end. So yarn start, that's it. What that's going to do is it's going to spin up NextJS on port localhost 3000. And then we can come down here to our fourth window and do a yarn deploy. Now, once you do a yarn deploy, there is a smart contract that comes with Scaffold-ETH. We're going to look at it in a second. It's going to take that and it's going to send it to the blockchain, send it to Hardhat, create the contract for you. It's going to tell you how much gas it costs to send it. It's going to tell you what the address that it was deployed to, and it's just going to give you a little bit of output, right? So let's take a quick look at it real quick, just so that we can see. So here we have our package, and inside of the repository, there's 3 subfolders in the packages. It's a monorepo, so it has everything split up into separate package repos for you. All that means is that each package has its own yarn package, so it's already set up. You don't need to know that. The main package is here, which has all of the scripts written for you, so if you want to reference that, you can. But what's important here is if we go to Hardhat and we go to contracts and we go to your contract, this is the smart contract that comes with Scaffold-ETH 2. So it's a very, very basic contract. The main thing you just have to take away from this contract is that it is a state contract that allows you to change a greeting, right? It has some other fancy stuff, like it creates booleans if someone pays to make a change. It has a constructor that sets the owner of the contract. But really, it's just a very basic contract. It's a total of 78 lines of code. We're not really going to get too much into the smart contract stuff because we're going to showcase adding a function and ingesting that data. But we can see here that we have an event that's emitted that keeps track of our greeting change. And then we have a function that allows us to set a greeting as well. So this function it's a smart contract function that takes in a string into memory called new greeting. It's publicly available and it's payable, which means you can pay some value into the function as well. And then it's going to log that to the console for us over here in our output in the Hardhat. And then it's going to allow us to change the greeting. And it's going to do that, and it's going to emit an event. So here it actually changes the greeting here, and then here it emits the event. So you can think of events as like logs. They're just a way for you to like log information that's happening in your smart contract. So anytime you do something, you usually, all good smart contracts emit events to keep that data available, right? And that's where the graph comes in later on. We'll talk about that, but the graph allows us to pick up these events and listen to these events. Okay, so we've deployed this smart contract on the Hardhat, and we have the server running. So what we can do now is actually load up our front end. So it's on localhost 3000. So let's go ahead and refresh. And I don't know why it's not loading. There we go. So this is Scaffold-ETH 2. So it is a NextJS application, right? And one of the things you'll notice when you first get here is there's kind of this like boilerplate like examples and like kind of like a welcome page. We're gonna gut this later. But the first thing I want to show you guys is this debug contracts folder. What's cool about Scaffold-ETH is if you start writing your smart contract, it's going to, if you've ever written a smart contract before, you might know that you have to create an ABI, or an ABI is created for you. The ABI is kind of like the map of how your smart contract works. And so, smart contracts are written down in bytecode on the blockchain, so they're not very human readable, right? So you need some kind of way to read that. That's what an ABI is. It's kind of like application binary interface. What Scaffold-ETH does is it takes the generated ABI from your smart contract, injects it into the front end here, and it builds this UI out for you. So it's a really good way for you to be able to start prototyping your functions, see how it behaves without having to start messing around and building out a UI, right? It's already kind of gone and built for you. So we can see here, if we were to look, there's a read function and there's a write function. So this one is a counter. Because we have a counter in our contract, basically the smart contract automatically has a get function, so it has a read function, which allows us to keep track of that counter. And we also have a write function, two write functions. One is called set greeting, and one is called withdraw, which allows us to withdraw funds. But the set greeting is what I want to focus on. We can look at it here again just to make sure you guys understand it. It's a function called set greeting, takes in a string, which is the string is here, and it also takes in a value if we want, because it's payable, and then it updates the function. So we can see right now that the greeting here is set to building unstoppable apps. So if I change the greeting to House of Web 3, like that, I could send some value, or I can just hit send. It's going to tell me, all right, well, you don't have enough funds to pay for this, right? And the next thing you'll realize about Scaffold-ETH, who here has used MetaMask before? Okay. So normally you need to connect MetaMask, right, to your dApp, right? If you've gone to Uniswap or whatever dApp you've used, you need to connect. Well, Scaffold-ETH comes with this concept of burner wallets. So you can see right here that we have a burner wallet that's built into the dApp. So we don't have to connect to MetaMask. We don't have to deal with local host issues with the nonce, because sometimes you get this weird thing where like your nonce counts off and then you got to go reset it in MetaMask. We don't have to deal with that. We just have this burner wallet. It's built into the browser. So if I come over here and say File, New Incognito window, and I go to localhost 3000, I'm going to get a completely new burner wallet, right? So and you can see that these burner wallets are different. Here I have this little green, pink blocky dude, and then here I have this kind of blue, purple blocky dude, right? So then I can start doing like, all right, let's test. If I'm a new user, I have these two burner wallets in completely different browsers, and I can start kind of transferring NFTs around or whatever it is you want to do with your dApp. We're going to close that for now. So there's this little button here just to grab some funds. So all I have to do is click that, and it's going to take 1 ETH from Hardhat and transfer it into my burner wallet. So now I have 1 ETH, which is equal to $1,822. That was easy. Too bad it's just play money. Otherwise, that would have been a good click. But now let's try to change it. So House of Web 3, send. There we go. It's successful. So I was able to change the state using this built-in UI that's built into this debug contracts. We can see that it changed here. We can also see an owner of the contract, which I'm not going to get into too much, but that's the Hardhat address that deployed the contract. Later on, you might want to transfer that, especially if you're going to deploy it to another network. But right now, it's owned by this kind of like deployer account. We have a premium that's like it's like a Boolean, and then we have a counter. So that will change from 0 to 1 because we just updated it. If I change it to SF and send, then that Boolean will change to 2. So we have this kind of like counter. So it's just changing state, interacting with our smart contract. Then we have the example UI, which is like a really pretty way of like doing some things. Like here we can set our greeting with this one and say, hey, what's up? This, hit send, and you'll notice that it's also sending some ETH in the transaction along with the gas. So it does that just by clicking this little button. And then now we've got the, this should change, there it goes. So we have this thing like checking state, the count went to 3, And now if we go to debug contracts, we'll see that the premium changed to true because we sent some value. And we'll also notice that the smart contract here now has a balance. Before it didn't have a balance, now it has some balance because I sent some value in the smart. So anyways, this comes with this kind of hello world smart contract. So let's keep going. Let's talk a little bit about the graph. Okay, so as of right now, if you're using, if you're building a dApp, I mentioned it before, if you want to read data from the blockchain, you probably are going to do like an ETH call against the contract and do a read against the blockchain, but it's not super efficient. And so we want to implement the graph, right? And the graph, you can, again, you think of it as this middleware layer that's going to expose a GraphQL API for our data, okay? So we want to do that. So let's come over here into the same directory. Let me just do yarn clean node. So yarn clean node is going to clean up if there's any existing data that I've been in this project before, and then yarn run node. So there's all these easy commands for you. So all you need to do is yarn clean node, yarn run node, and all it's going to do is spin up the Docker containers. So let's take a look at, while it's doing that, let's take a look at that Docker compose file. So here under, we're going to get rid of Hardhat for now. Let's go to Subgraph. Let's go to, I think it's under graph node. Yeah, Docker compose. Who here has used Docker before? A couple people. Good thing is you don't need to know Docker because the Docker compose file is already written for you. So you're really set up and ready to go. But I just want to briefly show it. The container has all the ports exposed. It has the database secrets in there. So if you need to change those for some reason, it's got some like environment variables. And you can see we have 3 different containers. We have the graph node one, IPFS, and Postgres. So it's going to spin up those 3 containers. And that is the stack. That's the stack for the graph. So if you are interacting with the graph in a decentralized way, that's exactly what indexers are running. And when you're querying the GraphQL API, you're literally querying one of the indexers, and they're running this stack, maybe in Docker, maybe they're running it, just they've pre-installed everything, maybe they're running Kubernetes. Either way, the point is that this Docker compose file is really everything you need to get up and running. So if you need to reference it to know what's going on, you can look at it. Yep, question, yeah. I mean, the default implementation is to use IPFS. They might be thinking about doing something different down the road, but that's recommended, yeah. Yeah, because that's where like we store like the a lot of the details about the actual subgraph are stored there. There might be a way to change it, but you would have to run your own implementation of the graph. Yeah. Okay, so we should be good. Everything is up and running. So now what we can do is we can actually go through and we can start creating our subgraph. So we already have the smart contract, right? Let's just say we're going to use the one that comes with Scaffold-ETH, right? Let's go over here and let's do a yarn local -create, which is going to create the subgraph for us. And then we can do yarn local ship. So we're going to ship that subgraph to our Docker project. So it's going to do, what it's going to do is going to build out the schema. It's going to take that subgraph, compile it, and then it's going to publish it to the actual graph node that's running here. And it's going to ask us for a version number. So you can think of the subgraph, as you make changes to your subgraph, you'll increase the version. So I'm just going to do 0.0.1, which is like the base version. It's going to compile it and deploy it to IPFS. And then it's going to give us, we can see that there was some success over here. It's going to give us this query URL, which is running on localhost 8000. So let's load that up real quick because I want to show. So we have this query, and now we can actually grab, so it's a graph IQL query search. And there's this cool like little explorer right here, which allows you to explore the data. So we can like see like what exactly we want to get. That's the beauty of GraphQL, is it based on the schema, the query language is really easy to understand, and you have this access to this query. So let's go ahead and let's go back. Where was it at here? Hit play. Let me grab a different query actually. Okay, so let's grab this query, paste this one in, and hit play. So here we go. So what do we get? So we put in, we want to get the greetings for the first 25 that are available. We want to order them by when they were created. We want to descend that order. And then we have ID, greeting, the premium, the value, when it was created, the sender, the address, and the greeting count. I hit play, which just did a query to the GraphQL API, and I get this data object. And I think if you guys remember, during my demo, I did 3 changes. First one, I said, House of Web 3. Next one I said was SF. And the next one I said is, hey, what's up? So essentially what the subgraph did is it went out to my blockchain, looked at the smart contract, looked at the history, and it grabbed all of those events and put it into the Postgres database, and then exposed it with the GraphQL API. So what we're able to do now is we can, instead of using ETH calls to grab the data, we can just do one simple GraphQL query against this data to update that. Okay. So let's assume that you want to start making changes to your smart contract. This is cool. This is out of the box. This package has all this for you. We really haven't written any code yet, right? So now we want to actually write some code. So let's go to our smart contract. And let's come here, go to contracts, your contract, and let's just create a new function. So I'm literally, just to save time, and for the sake, this is also in the documentation, I'm just going to paste this in here. So we're going to add a new function and a new event. And this function is going to say send message. So it's going to say, all right, we want to send a message from one address to another address, and we want to pass in the message as call data. We need it to be externally available. And then when we do that, we want to, this is probably not the proper way to send a message on a blockchain, but it's a really good basic example of what you might do to emit an event. We're going to say the sender is who it's coming from, who it's going to is who is in the address field to, and then the string of the message is going to be the message. So let's save that. So now we've made a change to our smart contract, right? So what do we want to do? We want to deploy that change. So we would do yarn deploy again, and we did that at the beginning, right? The trick here is if you ever want to force a new contract, you can also do -- reset. Oops, sorry. All right. Reset. And what it's going to do is it's going to force a new copy of the contract, and it's going to publish that. Now, you would think that the subgraph, or the graph would pick up that, right? No, because we haven't programmed the subgraph for our new function. So we need to actually create a new subgraph for that. So first of all, let's just check and see at our smart contract. So we've made this change. We can go back to our Scaffold-ETH. We can go to debug contracts, and there we go. We have this new send message function. So let's send a message to vitalik.eth. What do you guys want to say? It's all local, so he's not going to actually get it, but you are cool. All right, so I'm going to hit send. So transaction successful. I get a receipt. I can see that it was successful. I was able to make that transaction. So I sent vitalik.eth a message on my local machine using Hardhat, and it fired off. How can I get that information? It's kind of difficult to get. We don't have it automatically built in our UI here. It gets a little foggy, right? So let's do it with the graph. Okay. So let's go over to first our, now we're going to learn about the graph. We're going to dive a little bit more into the graph. We've made a little simple change to our smart contract. Let's go, and we're going to focus on the subgraph now. So creating a subgraph is a few things. By few, I mean 3, really, that you have to do. You have the subgraph YAML, which is considered the manifest that keeps track of where the ABI is that I mentioned before. It keeps track of what contract you care about. It keeps track of what network that you care about in regards to indexing. And then it also keeps track of what entities that you want to keep track of. So the graph uses this concept of schemas or entities, the schema configuration, which is basically just a way of how you want to organize your data, right? You can think of it like you have a database, you want to keep track of the table of that data. So that's exactly what the entity is. And then we have these event handlers. So that's the 3 parts of the graph. It's the manifest, which keeps track of this at a high level. We have the source schema, which is here, which is the actual data types. So you can see we already had one for the greetings, and we already had one for who the sender was for those greetings. And then we have the mapping file. The mapping file is like, we call it the handler. Okay, so it's the handler of what happens. So this is all written in assembly script. It's a subset of TypeScript. So you can't do everything that you can do in TypeScript here, but you can do, if you have some experience with JavaScript or TypeScript, this is probably fairly easy to understand. The main thing that we want to look at is we use this thing called GraphTS, which is Graph TypeScript, which is a tool managed by the Graph. And we import our contract, and we import the schema, which has the objects that are inside the schema that we care about. And then we do these functions that allow us to do something with the data. So in this case, what we're doing, the existing one is keeping track of the greetings changed, which we've already been kind of using. And it's basically taking the data from the blockchain, converting it to the data that it needs to be able to store. It's doing a timestamp. So there's a lot of interesting stuff happening here. And then basically in the end, we save the greeting and we save the sender. And we save that to the database. Okay? So that's exactly how you get data from the blockchain into the graph, is you create these subgraph configurations, which is these three things, and then you deploy them, which we're going to do here right now. So let's do it. So the first thing we talked about was the subgraph YAML. We don't really need to change anything there yet. I want to focus on the schema first. So we already have these two objects, right? We have the greeting and the sender. Let's add a few more. So let's add these three. So we want to keep track of the message, the messenger, like who sent the message, and then who the receiver was. This is probably not the most optimized subgraph, but it at least shows you how you might create 3 different data objects for different parts of your event. And then we also have this derived from field, which if you want to optimize the graph and how it indexes data, you don't want to replicate data, you can use this derived from field. So we're deriving from the from here to keep track of the messengers. And then we can save that. So save the schema. The next thing we need to do is go into the subgraph manifest, and we need to add the handlers. So let's do that. So let's come here, or entities, sorry. So let's add the entities. So we had the greeting and the sender in there, but we added message, messenger, receiver, which is coming from here, right? We're going to import those. And then now we need to add the handlers, the event handler. So let's do that. Get rid of this, like that. So now we have a new handler. So before we had the greeting change handler, which is the inside the mapping TS here, right here, handle greeting change. And then now we're going to add another one. So we need to add that event handler here. Again, you can think of the event handler as like telling the subgraph what you care about in the fields and how you want the mapping to handle that data. So let's save that. And then now let's grab the, let's make these changes. So before we were importing your contract greeting change, but we also need to increase, do send message. Oh. Send message, comma, there we go. All right, let me grab it here. Oh, I need to also generate so one thing before you do this is you need to also generate the ABI. Because we made changes to our smart contract, we need to pass the ABI off to the graph so it knows how to read it. So we need to copy it across. So you can do that with yarn ABI-copy. It's going to copy the ABI over for us. That's why it wasn't able to see it here. And then we also need to do yarn code gen, which is going to generate the code we need. There successfully, it creates the types. And so now we should be able to do this. There we go. Now it works. Okay. So now we can do the event handler. We did that. Okay. So now we need to add the additional fields here, which I'm just going to grab this whole thing and replace this. So let me do that. So here, before, again, we were only importing the greeting and the sender, but now we need to do these additional entities from the schema. So we need to keep track of these data objects. So I'm going to ingest those 3, right? And they're not highlighted because they're not being used. So now we just need to create an event handler. And I'm not going to type this whole thing out, so I'm going to copy paste this one as well. But essentially, it's just another, it's a very similar to this one, which is keeping track of the greeting changes, but it is doing the same thing for those 3 entity types. And then at the end, we're saving those entity types. So you can see here where we're actually converting what we need for the fields that we get from the handler, and then we're saving those into Postgres. So save. So I've made changes. So those are the 3 changes you have to make. You got to create your schema entities. You got to update your manifest to care about the entities that you care about. You need to update the handler, and then you actually need to write the handler. Does that make sense? Okay, so now we have this new subgraph that we want to deploy. So all we need to do is come over here and do yarn local-ship. And what that's going to do is take our subgraph and it's going to publish it to our Docker instance. It's going to compile it, and then it's going to ask us a version number. So what version are we on? We're on 0.0.2 because we've made a change to our subgraph, right? So let's do that, and there we go. So it's the same URL. So let's go back to our browser. Let's go here. And now let's grab a new query. So before we didn't have any data in there for the senders and stuff like that, but now we do. Let's refresh real quick with the Explorer. Now we get a lot more entities, see? So we have access to that. So let's type it, let's do this one. Let's grab the first, actually let's grab the first, yeah, we only did 1. Let's do first 5. Order by created it, ascending. We're gonna choose the ID and hit play. There we go. So there's my message to Vitalik. You are cool, right? So now we've been able to ingest that data into our front end. So the only thing missing here is our front end, okay? So we've kind of dived into like writing a smart contract, creating a subgraph based on the function that we created and the event that we emitted. We deployed that to the graph instance. Now we want to actually like display this in our front end. So let's get started on that. So let's show, because right now, if we look at the front end, let's take a look. So again, we used NextJS for the graph, or for Scaffold-ETH. And inside there's a pages folder, and then there's this components folder, and then there's an example UI right here. And then we can look at contract data. Okay, sorry, not contract data, contract interaction. No, sorry, it is contract data. So if we look at this page right here, let's go back. We go to example UI. That's what we're looking at here, contract data. And you'll see there's some boilerplate code in here. If we scroll down and we go to here, where we have a GraphQL query that we're formulating. And then we're using GQL, which is just like a GraphQL query language package for NextJS. And we're querying that at a poll interval of 1,000. So every 1,000 milliseconds, we're grabbing it. And then if you come down here, we can actually look, there's a console log, I believe, somewhere. If I can find it. Oh, there it is, right below. So we console log that to the console. So let's take a quick look at that real quick. So let's go to our thing. Let's go to View. Let's go to Developer Tools and refresh and go to Console. There we go. So we can see here that we actually have the data object here for the greetings in here as well. So we could actually come in here and see this is a GraphQL query, and we can see what that data looks like. But we're not actually using it. We're just logging it. So my point is that you can see this as an example of how you would query, but we're going to actually write a complete page. So I'm going to get started on this, and then we'll take a small break, but let me at least show you what we're going to do. So first of all, we're going to go to the index.ts file here. And this index.ts file is this kind of very first page that you get when you come to Scaffold-ETH. It's not really necessary. It's not needed. So we're going to kind of gut it, actually. We're going to come here and grab, I don't know why I keep doing that. I'm going to grab all this stuff and kind of get rid of it. Let's do it like this. Okay, like that. So we save that, and then it's kind of like wiped clean slate, right? So what we want to do, let me show you this part of the thing. So we've made it all the way through this stuff. We've updated the event. We've shipped our subgraph. We tested it. Now we're at this front-end development. This is kind of like the missing piece, I think, for a lot of developers that are getting into this space, is they don't know how to build the front end. Now, what we want to do is build a couple things. We want to build an address component and a balance component for our wallet that's connected. We want to do an input field to update our greeting, and then a button to actually change the greeting, which is the equivalent of what like you do here, right? And then we want to create an input field for our receiver, for our message, and then we want a button that sends that transaction. And then we want a table to be able to display our messages, okay? And actually there's also like a variable for the greeting as well. So we want to do that stuff. So the core stuff that you need to do that comes with Scaffold-ETH. It comes with everything you need. It's just in different areas. So one of the things is Wagmi hooks, which if you're not familiar with Wagmi, we're all going to make it. But they have a hooks package that allows you to read data from a blockchain or using whatever framework you're going to use, particularly JavaScript or TypeScript. There's also Scaffold-ETH hooks. There's also Scaffold-ETH components. And then there's some also additional documentation for Scaffold-ETH here. So if you guys get lost in any of this stuff and you want to kind of dive in deeper, these are the good 4 links for you. But let's go ahead and start doing this. So we have this existing kind of bare bones page. We're not using link anymore, so we can get rid of that. We're not using the anti-con as well, so we can get rid of that. We want to import the stuff that we're going to need, okay? So if we grab this stuff right here, we want to get use account from Wagmi. Let's just paste it in here so it'll look prettier. We want to use account from Wagmi. So use account is going to allow us to look up account data for our wallet. We want to use the address input, and balance of Scaffold-ETH components. We also want to use the account balance, use deployed contract info, use contract read, and use contract write from Scaffold-ETH. And then we want to use state because we're going to keep track of the fields that we're typing in as we type them using React. And then we need to be able to do the GraphQL query. So we need GQL and we need the Apollo client use query. So these are both from Apollo client. So that's pretty much everything we need in our front end to build out our UI. So let's go through and start kind of doing that. So first thing we can do is we want to add a address and balance component, right? So we can keep track of our current connected wallet, the current address that it's listed using this Scaffold-ETH component and Wagmi. And we can also use, so we can grab this and let's paste that down in here. Okay. Now we don't have the data we need, so we need to grab the data. So this address component, again, is coming from Scaffold-ETH components. The address here that we want to get needs to come from Wagmi. So we can do that with just this simple line right here. So we're going to create a const with the address data object right here. I think it needs to go. There we go. And save that. So let's take a look at what it looks like. So there we go. So we've created this. Like I said, it comes with the component. It's got a little cool copy button, so you can copy it to your clipboard, and then it gets the balance of our smart contract. It's essentially what you see right here in the top right corner. Okay. So that is using those 2 components. The next one is we want to create to show the current greeting. So we already can grab that, or we can create a div here for that. So we'll put that right below. Put it here, I think. And then we need to actually grab the data. So for this one, we're going to use scaffold contract read. And you can see it takes in some objects. So it takes in the name of the contract that we care about. And it takes the greeting function that we want to read from. And it returns some data. Okay, so let's copy that. Okay, and then let's save it. Let's see if it updated. Oh, I haven't set the greeting. All right. Oh, there it is. It's down here at the bottom. It's very ugly. I didn't put it in the right div. That's why. So let's move it here. Let's put it there. There we go. So this is the current greeting. So you can see it's really easy to read the data from the blockchain using that. We're going to get into how you do it with the graph in a little bit because we're not going to get we're just getting the current data here. So it's not like super crazy that we're getting like a large GraphQL query. But when we get into sending messages and we want to send a lot of them, then we need to consider using the graph. So I'm going to showcase that. The next part is we want to create something that keeps track of our contracts balance. So let's grab that here. Did you have a question? Or no? No? Okay. All right, cool. So for this one, we're going to use we need the your contract object. And in order to do that, we're going to use deployed contract info, also from the hooks that come with Scaffold-ETH. So here we're passing in the contract name, which is just your contract. We can get that from the contract. And then it's getting an object back called your contract. So we can paste that in. So you can see how we're doing. We're just building out the data we need, and then the front end we need. And you can see as we start using these different components, they'll highlight that they're being used. And I'm just copy pasting to save you guys from the torture of my typos. So now we can see we have another tab here, which is keeping track of our contract. We can verify that by going to debug contracts, and here it is. We can see here that it's listed. It's the same as this one. It doesn't have any ETH. So that was successful. And then we also have this ability to do, let's make a set greeting function. Okay, so let's grab this one. So what this one does is it's saying, okay, well, we have a div, we have an input field, which is going to need to have some state. So we're gonna have to create state here in a second. But what's important here is we're gonna use the set new greeting for the target value that is coming from state. And we're gonna put that in, and then we just have a button that on click is going to set that greeting using the set greeting function. So let's copy over the front end side. So we'll do it here, we'll do it right below, right? Save that. So we don't have this data yet, so we need to get that. So here, this one, we're gonna need to use state. So we're gonna create, if you're not familiar with React, essentially you need to keep track of like the state as you're typing something into a field so that you can update it and keep it stored in the application. And then you can have two functions within there. One is to set the new greeting and one is to new greeting. So we can grab this. Let's paste it right above here. So we have this state that we're keeping track of, which is the new greeting that we're going to set. And then here we have this write async function of use scaffold contract write. So use scaffold contract write is also a component of Scaffold-ETH hooks. So it allows us to pass in a couple arguments. Actually, it passes in three things: the contract name, which is your contract, the greeting name, or the function that we want to set the contract, so set greeting, and then the value that are coming from the args, which is what we're keeping track in state. So here we're keeping track of what we type as we type it. So let's save that and just test it. So if I come over here and I start typing, I say hello, that's being saved in state. And then now I can hit set greeting, and it's going to update for me. And there it is, made a change right there. So you can see how we're kind of just piecing together different parts of Scaffold-ETH to do that. Okay, so the next part is we want to create a way to send a message from here without using the debug contracts. So this one's a little more involved, but we're going to use what's really cool is this address input function. Address input is really cool because it has that cool like detection of the ENS avatar, and it's got the pretty display there, and it does ENS resolution as well. If you're not familiar with ENS, but ENS is like if you have an ENS name, you can have a short name. So let's add that. So here what we're going to do is we're using address input, and we're also going to need to keep track of this in state and this in state, which we'll create here in a second. But the difference is this address input is a component of Scaffold-ETH that allows us just to easily, quickly add an address. You'll see it here in a second. And then we have a field that's going to keep track of our message, very similar to what we were doing earlier where we were changing the greeting. And then we just have a button that's going to have an on-click send message, but we don't have this stuff defined yet. So let's go ahead and define that. So this one, we need to create a use state for each thing because we need to keep track of who the receiver of the message is going to be. And we also need to keep track of the message that's being typed into the box. So we have two different states that we're keeping track of. And this is probably not the optimized way to do this. I'm not a front-end developer. So by any means, if someone wants to tell me this is a better way to do it, let me know. But what's important is we're going to use scaffold contract write to do that. Just like we did before up here, we use scaffold contract write, which is a hook for Scaffold-ETH. The difference is that we're going to pass in two arguments this time, the receiver and the message, because our smart contract needs two arguments for this function, right? Whereas the first one just needs the function or the greeting. So let's put that in right above here. Save. Now let's take a look at it and see what it looks like. So now we have this recipient. Now if I type shutterblock.eth, that's me. You see my little punk icon, and you can see the little blocky dude. So it's kind of a cool little address input field that just feels a little bit nicer than you just having to paste in a 0x whatever blah 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 address. It supports ENS resolution. You also could just copy in and paste an address like that, and it would do reverse lookup as well. So if you have your avatar set for your address, it will do it. And now we can say foo like this, send a message, and it works. So you can see how we start building out our UI. So now we want to get to the point where we're going to display our data in the graph. Now, if this dApp, I sent messages to everyone in the room, right? I would fire off all these messages to you guys, and we can actually just fire a bunch off. Let's just kind of spam it a little bit, so we can kind of like force it. If we were to query that using ETH hooks, we would have to loop through, right, and get the data and query it in that loop. That's where the graph comes in, right? We're just going to do one simple GraphQL query against our GraphQL thing, which I should be able to now hit play, and so we get all those here. Now I can do like first like 25 play, and we get them all here. So we see that instant GraphQL data. It's a beautiful thing. And so now we want to build out our front end to display that stuff. So this gets a little more, I guess, noisy, I would say. Here we're going to create a table that's just keeping track of from, to, and the message. And we're going to use a key lookup on the messages that we're going to get. So it's going to be a data object called message. And it's going to keep track of the ID of the data. And then it's going to display who it came from, where it went to, and what the message was. So let's put that into our front end down here right below. Save that. And then we want to grab that data. So we already know we want to use the GraphQL. So we have our query here, which gives us the first 10. And it's order by descending, order by created date. We can hit plus or copy that. And then let's copy and put that in. So that can go right below here. Oh, this one needs to be outside of the main function. So it needs to go here because it's globally imported from the app. So this one we can put into the thing. So this is kind of important. So what we're doing here is we are using useQuery, which is the Apollo client, to use the query that we define up above, which is right here. And we're getting back any kind of loading message, we're getting back any errors, but then we're storing the data in a value called messages data. And then we're extracting that data into an array, essentially, here. So let's copy that, put that right below our existing boilerplate code here, like that, save. Now let's go back to our front end. Oh no, what did I do? Oh, there it goes. Okay, there we go. So now we get all of our data available quickly in one simple API call. Let's see how quick it loads. If we were doing this on the blockchain and we were having to go through and loop, it would take 100 milliseconds per message, right? So let's change that to, I don't know, let's change it to like 20. Let's change it to 100. Refresh. And then let's just spam it. Let's just see if it keeps track. So we can go semvitalik.eth message. Yeah. All right. So we can see how quickly that data got into the graph, right? Smart contracts were invented. My battery's about to die. Oh no. Let me grab my charger. Let's take a 10-minute break, and then I'm going to show you guys how to deploy this smart contract to a public testnet and how we can deploy it to the Subgraph Studio. Does that sound good? Cool. All right. Whew. All right. Didn't die. Yeah. Can you temporarily mute me, actually? Can you mute me for now? That way people don't hear me chomp. Okay, so how's pizza? Good? Sweet. All right, so you've built this dApp. It's all running locally. You've gotten to this point where you're like, all right, I'm going to send this to my buddy. um, the first thing is like we're using like Hardhat accounts for all this stuff. And by the way, don't if you guys have to run because I know we're close to the time of the project. If you have to leave, I won't be offended. Don't feel bad. This is all live stream is recorded, so you guys can always watch it later. But we've been using Hardhat accounts. The thing about Hardhat accounts is everyone uses the same Hardhat accounts. So you don't want to use those Hardhat accounts to deploy your contract to a public testnet because you need to fund the account to deploy it with some ETH on the testnet or on mainnet. And everyone has those private keys. So the minute you fund one of those private keys, it's going to get drained because someone's just running a script that's draining that stuff. So what we want to do is generate a deployer account. So this is cool because it's actually built into Scaffold-ETH to be able to do that. You just go yarn run generate or yarn generate, and it's going to create a wallet and save it in the private key in an environment variable locally on your machine. And what that's going to give you the power to do is essentially fund it. So we can do yarn account to get our address. So we just created one. And it's going to give us this fancy little QR code if you're using, using your thing. So we have this like public address. So I can come over here. I can say, oh, let me bring up my Punk wallet actually. So you can use any wallet, but I'm going to use my Punk wallet, which has some funds. And I'm going to bring it up here. I'm going to scan. And I got the address here. And I'm going to send on Sepolia. Yeah, sure. Sepolia. Let's send ETH. Let's send 0.05 ETH. Send. Oh, what happened? Do I not have enough ETH? Maybe I don't have Sepolia-ETH. Oh, I don't have any Sepolia-ETH. All right, let me do it a different way. So we can just grab the address. I will load up my browser. I will go to Firefox, and I will send some ETH to this address. I will send 0.05. You don't need much because we're just deploying to a test net, and it's a really small contract. Obviously, the larger your contract is, the more gas you're going to use. So let's send that. So I sent 0.5 ETH. So now let's come over here. So you're on account again. Might take a second for it to go through. What it's going to do, there it goes, already went through. So this thing is going to go through and get all your balances on the chains. So we already have 0.05 ETH in that deployer account. So now what I can do is I funded the account. Now I can deploy it with just one little network flag like this. So I can say yarn deploy -- network Sepolia like this. Okay. This is going to take my contract, see if there's any changes, compile it, didn't need to. Now it's going to send the transaction using my deployer account. And there it goes, it was deployed. So now we can look at that up on Etherscan. So here we have the contract. Let's go to Sepolia Etherscan, and let's search for it. Here it is. I've already created this contract, so it's already verified because it's the same code as another contract, so the hash matched. So sometimes you would deploy the contract and it would not be verified, but this one, in this case, it detected that I've already deployed it and it's verified. So we can see here that it's here, it's been deployed successfully, and we can see our source code. If we wanted to, we could do yarn verify if it wasn't, -- network Sepolia. So real quick on this. So the concept is like when you deploy a smart contract, someone was asking me earlier, like, how do you know like where a smart contract is, or how do you know how to get to it, and how do you know what it does, right? Well, that's the whole point of like the blockchain is you're deploying your smart contract to the blockchain, you get back an address, and then that's kind of like your way of saying like, all right, well, here's my address. You can trust this. And I've also gone ahead and verified it. And what you're doing is you're taking a copy of the source code and you're sending it to Etherscan, and then Etherscan is saying, all right, cool, let me compile that and make sure that it matches what's on the blockchain. And when it does, then we know that those are identical. So it's impossible for you to verify a different contract based off of that because it compiles down into the same bytecode. I didn't really get too much into that, but all the smart contract language that sits on the blockchain is in bytecode. That's why you need the API to be able to read it, yada, yada, yada. So we've already verified it. We're good to go. We can verify that by coming here. So that way, if you send this to your buddy and you say, hey, put some ETH in here, you can be like, well, what does it do? And you can look here and look at the source code, right? See what it's doing. Make sure it's not like fraudulent. Okay. So now what we want to do is we've already deployed to our contract. We've verified it on Etherscan, which it was already verified. Now we want to look at the graph. So currently we have a subgraph built, but the subgraph is being deployed on our Docker instance, right? So what we want to do is use Subgraph Studio. So Subgraph Studio is just a way for you to, if you're a developer and you're creating subgraphs like we already did, it's a way for you to come in and create subgraphs for your smart contract and then deploy them to the decentralized network. So we can come here and let's say create a subgraph. We'll call it send message. It's available, so I'll use that, send message, because that's what we did. We created a function that allows us to send messages, right? And then you choose a blockchain. So these are all the blockchains that we support. So Ethereum, Optimism, yada, 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 Polygon, Avalanche, but we deployed to Sepolia, which is all the way at the bottom. It's one of the last ones we added. So here it is, Ethereum Sepolia. Create subgraph. So now we have this kind of like skeleton subgraph in the studio. If you hadn't signed in, you can sign it. You need to sign in with your wallet to be able to interact with this. Let me just show you what that looks like real quick. I'll hit connect, MetaMask. It's going to ask me to sign and sign the message. My subgraphs, there we go. So the first time you come here, you need to do that. Then you can create a subgraph. It's going to give you 1,000 free queries for you to test your subgraph. You can sign up for an API key if you want to do that. If you want to query like subgraphs that are already created, like Uniswap or that aren't yours, you need an API key to do that. If you want to query a subgraph that you created, we give you a development query URL, so you don't necessarily need to use the API key, but it's a hosted solution, so it's a hosted service solution. Eventually, you would want to take your subgraph to the decentralized network. I'm not going to get too much into that, but I'll explain it in a little bit. Okay, so we have this kind of like bare bones one. So all the steps are actually outlined here on the right. To deploy your subgraph to the decentralized network, or to the host, I should say, to the Subgraph Studio, you need the graph CLI. Okay, so you can use npm or you can use Yarn to do that. So let's do Yarn. Come over here. You type it in. It's going to do. I don't know why did I not copy it right. Let me do this because I'm going to open up a new cd mkdir. We're going to do this in a new directory so we don't mess up our existing Yarn package. Testing send message. CD testing. Okay, let's do that. Try it again. Okay, because if you already have a Yarn package, it might mess up your Yarn package repo. So okay, so we installed the CLI, so we can do like graph dash help, something like that. Oh. Let's try this. I don't know why that's. Oh no, I didn't mess up my thing here. Hold on one sec. I might need to actually remove this. There's a new version of the CLI or something. Let me see. I just removed it, reinstalled it. Let's see if that works. There's always going to be some live demo problem. I'm surprised I made it this far without any more problems. All right, let's try it now. There we go. So now it works. Okay, so we got the graph installed. So we can init like basically an empty repository, but by doing graph init --studio send message like this. And it's going to give us like a little bit of adventure selection here. So let's say, all right, we want Ethereum because it's an Ethereum address. And I think actually, it's an Ethereum. Yeah, it's Ethereum. And then send message, where to create the directory. Oh, here we go. And then we need to choose the network. So it's Sepolia, which is a test network for Ethereum. Now it wants the contract address. So we have that here. So let's grab it. Boom, paste it in. It's going to go out and grab the ABI for us. So I talked a little bit about the ABI. It's this kind of like map. And why that's important is if our contract was verified and we've sent our ABI to Etherscan, it's going to be able to be smart and create the entities we need for us. So I'll show what that looks like. But what it doesn't know is the start block because it's not smart enough to go out and grab the start block. So we can grab that here at the transaction and we can see when it was deployed. So it was deployed 7 minutes ago, which was block 409 or yeah, I don't even know how much, 4 million? Yeah, is that right? Yeah, 4 million blocks ago. So let's grab that and then name it contract. And then this is the important one. Do you want to index the contract events as entities? Yes, because we want to like parse the events and create an entity for us so we don't have to write it. So we say true. And what it's going to do is initiate a yarn package for us. And it's going to, this is nice because then you could just store this in Git and you can have your subgraph configuration that you can easily build at a later time. So do we want to add another contract? No. There we go. So now we can go into send message. And the next thing we need to do is authenticate against the studio. So you get a key, essentially, when you sign up to the studio that allows us to have a link between the CLI and the studio. So we're going to do that. So we'll authenticate. And then we're going to do the same thing we did before. We're going to do a code gen. We already have the ABI uploaded, and it's already been downloaded into the project. But we need to do the code gen just like we did before, and we need to build it. So we're going to do that. Code gen and build. Okay, and then we need to send a message, or actually deploy to the studio. So that it's the same stuff we did before locally to Docker, but we're now doing it to the studio using our package. So now it's going to the same thing. It wants us to know the version, so we're at 0.0.1. So we've deployed our contract to Sepolia. Now we've deployed our subgraph to the studio. I don't know why this is doing this for me, but it was successful. Let's just double check and make sure. 0.0.1, it should say it already exists. Yes, okay, so it's there. So let's take a look at it. So now we can go over here to Playground here, and we can hit play and try to get some data. We don't have any data yet because we haven't actually interacted with our smart contract. Now, if you're familiar with Etherscan, Etherscan has this cool option where you can insert your connection. So you can go to write contract, and you can connect to Web3, connect to MetaMask, and I'm already connected, I think. Now I can send a message. So let's send it to here, I guess. Let's grab this one. This one here. Grab this address. We'll send a message to this address. We'll say hello from House of Web3. Hit send, right? We're just going to propose a transaction. So before we were using burner wallets, but now we need to use this concept of like signing a transaction using MetaMask. So let's do that. So now we're taking our transaction, we're posting it to the blockchain. Should happen fairly quickly. It's a little slower than localhost. So now we can come back to the studio and hit play. And it might take a sec for it to do. It says it's synced or syncing. It should be fully synced here in a second. Hold on 1 second. Let me just go down to where I need to be. Wait. Okay, we authenticated, we deployed, we code genned. Let's see if it worked. Let's grab this query URL actually. Let's grab this one. So we're going to grab the messages, first 5 from the ID from to message, hit play. It's not there yet. Let's see if it was successful. For some reason, I don't think it actually sent. Let me try it again. Oh, view your transaction. Success. Okay, so it should work. So it should be in GraphQL. Let's try again real quick. Okay, that's That's weird. Did I do a different version? No. Okay, I'm not sure why it's not showing up actually. Let's do it a different way. Let's go over here to our front end. So we've deployed our smart contract to Sepolia. We've published our subgraph to the studio. Let's take our application and let's go to the scaffold config. So there's the scaffold config file and there's a target network setting. So we've been using Hardhat. We want to switch to Sepolia. So let's change this to Sepolia first, save that, and then let's reload our app. So the first thing you're going to find out here is that we lost burner wallets because we're not using burner wallets anymore. We need to connect to MetaMask. So now we need to be able to connect here. So let's connect and let's refresh. We're still getting the old data, so let's ignore that for now. But let's go to debug contracts and let's go to send message. Let's do this one to vitalik.eth and do, hey, I think you're cool. Send. Oh, didn't connect. I was having weird issues where it was like kicking me. Okay, so let's try this again. Hopefully I did my subgraph configuration right, but I think it should be good. I just want to take a look at it real quick. Let's see. Is the address, is that the right address of our smart contract? 92, yeah, that's the right one. Okay, let's try again. Let's refresh. It might take a sec for the data to get into the graph. Sometimes, you know, there's like a cron job or something that's running where it's going through and, oh, there it goes. Now it's at 100%. There it goes. All right, cool. Now it's working. So I don't know. I think my transaction on Etherscan didn't go through something. I don't know why. But anyways, this one worked. Oh, that's the hello from House of Web3. So that one should be work. So that's the first 5, and that was available. There we go. There's the other one. So it just took a sec. So I think it takes about 5 seconds when you're using the studio for it to start picking up and start indexing data. Okay. So we have our subgraph in the studio. The first thing you'll notice is when we created our subgraph using the CLI, it's different. Okay, so it's a little different. Let's look at the schema. It's a little more simple. It's got the greeting change entity and it's got the send message entity. So it's got just 2 entities. Before we had 5, right? So it was a little more complex. And we also can look at the source, where is it at? The subgraph YAML. It has the same though, and it has less entities because we're keeping track of less entities, right? And then the contract TS is what we're doing, the handler. So it's a little more simpler as well. So it's a more simpler subgraph. We could go in and copy paste what we did before and paste it here and then redeploy it and it would work. But just for the sake of like time, I'm not going to do that. So we can close this for right now. So let's get going on updating our, so what do we need to do? We've updated our chain in the front end here so that our front end is using Sepolia, right? But we haven't updated the API area. So let's go into here, into the NextJS, and let's go into the pages and go into app TSX. So here we have the subgraph URI right here. This is what we need to change because we want to point it now at our subgraph studio. So we go to details, and there's a development query URL right here. You can grab that and put that in here. Oh, sorry. So we need to grab this, paste it in. So now we have the new query URL. That's it. We're just changing it from localhost to now using the Studio's API. And then the next thing we need to do is update our data structure for our front end. So because we were doing it before with like a more complex GraphQL query, we're going to use this more simple query here to get the messages. God, this is so irritating. I need to turn that off. So grab this. So for this one, we're just going to use, oh, what did I do wrong? Oh, that's why. Sorry. There we go. Okay. So this one, we're just going to get the messages. The first, let's actually change it to like 20, 200, whatever. Doesn't matter. Save. And then we're going to update the table as well because the table was in the wrong format. So let's come down to the table and let's put the proper syntax in the table. This is all in the GitHub repo, so don't feel like you are going to get lost here. Okay, save. Okay. So we should have everything we need. Let's take a look at the front end. Did it work? Oh, it didn't. It's not getting the messages, so let's see if that query actually works. What? Send messages. Oh, we just need to use this. Okay, there's something wrong with my query, but let's see if we can do it manually. Let's see, messenger, messages, created at ID, messages, ID, message. There's the greetings. Let's grab the one from the studio. But I thought that was working for us earlier. Yeah, that's working. That's kind of weird. Maybe I just didn't copy across this correctly. Let me just double check the code. First one is get messages, GQL. Oh, the data object is wrong. That's why. So here we need to use the messages. It's just, there we go. Let's try it now. For some reason, Scaffold-ETH keeps kicking me out of the burner wallet too, or there it is. Okay. So basically what we just did is pointed the UI at the GraphQL API instead of the local host, and we changed the query to be to the new entity type that we used, because we changed the data structure, and then we updated the table to match the query, and then we displayed it here. So we got the to and the from and the message. Those are working. The next thing we want to do is then take our app and ship it so that the front end is decentralized as well, or not decentralized, but deployed. We're going to use Vercel. So we're going to do, all we got to do is do yarn Vercel YOLO. I'm in the wrong repo. Yarn Vercel YOLO. So yarn Vercel YOLO is going to ignore build errors. So set up and deploy, yes. Kevin Jones creates, link to existing project. No, what's your project name? We'll just call it message test. Current directory. There we go. So now what it's doing is taking my source code, it's building it to make it optimized for Vercel and ignoring build errors. That's what YOLO does. And then it's going to send it to Vercel. Who here has used Vercel? So Vercel is just like a static file hosting service, essentially. There's a bunch of you get like a free tier. You can host like little static web pages. When you first sign up for Vercel, it's going to ask you to log in here. So you can log in with your username and password. Obviously, we skipped that because I'm already logged in. And then it's going to create a project for you when you do Vercel YOLO. And it's going to take the package, it's going to bundle it up, build it to be optimized for a static file, and then it's going to ship it off. So this might take a second, so we'll let that load. But I'm very surprised that we actually made it through fairly quick to all that. I know that was a lot of information. While that's doing that, there's a bunch of links here as well. I linked the Wagmi hooks, Scaffold-ETH hooks, the components. This is my contact information. This is a mirror XYZ post that I talk about Scaffold-ETH and the graph. This is a bunch more links for Scaffold-ETH if you want to learn more about that. These are a bunch of workshops I've given on Scaffold-ETH. and also graph workshops at ETH Global events. And there's a bunch of really cool information here. If you're just getting into like Ethereum development and Web3, these are really good resources that are made by people in the community for Scaffold-ETH. One of them is like a curriculum from Web 2 to Web 3 from Austin Griffith, who's the creator of Scaffold-ETH. That's really awesome. And then Natter's Web 3 resources for developers. He used to work for the Graph. He was a DevRel there. He has this full list of like resources. And then there's also Edda's, which she's a core member of the Build Guild as well. Let's see if it finished. It's not done yet. Bristol's a little slow. So if you really, really, really wanted to be decentralized, you probably would take this and package it up and store it on like a decentralized file service like IPFS or Arweave or something like that. There it goes. Finally finished. Okay, so now we can go to message test -lemon. I always love the names that come up. So now this is fully decentralized. So we're using our subgraph. We're using a testnet. We'll connect to the wallet. Connect. There we go. And we can propose a message here. I can send a message to Vitalik again. This time he might see it. Okay. Send message. Confirm. Cool. All right. What kind of questions do you guys have? Thank you for sticking through that. I know it was long, and but anyone have any questions I can answer? Yeah. No.
Yeah. First of all, great talk.
Thank you.
I really enjoyed it. I'm new to the back end side of things, and I was wondering about smart contracts being deployed to blockchain. Just by analogy, would that be something like a GitHub repo? Like the code is visible on the chain, and then if I was like to use that code to deploy, I was to try to deploy that code, what would be what processors?
Yeah. So like we can look at like this. So if we look at the contract here and we see the transactions, we can see, let me refresh it actually. We can see all of our transactions here. The very first one, when you send a message to the blockchain, in this case Ethereum, for like the first time, and you send in the call data to do an account creation or a contract creation, you literally are sending all of the bytecode for the contract as like this kind of blob of call data, and you're sending it, and then the blockchain picks it up and says, all right, cool, I'm going to create this contract for you, and then that's where it lives, right? No, the Etherscan is the one doing the verification. So Etherscan, you can think of them as kind of like the library of like all of the smart contracts and transactions. It's just a more common source of truth, I would say. If you can't always be 100%, but you can almost guarantee that the contract information that's listed here, unless someone came in and hacked the Etherscan servers, is fairly reliable and trustworthy. Yeah, exactly. So there's always a way that something can happen. I mean, some of the biggest hacks in Ethereum have been related to some kind of Oracle issue or third-party non-blockchain tool, right? So there's always, but for the most part, the concept is someone's providing their, now let's say it was like Uniswap, right? Like Uniswap, all their source code is on GitHub, so you could technically check out the repository, compile it down using Solidity compiler, and verify yourself. Because you could go to the transaction, you could look at the call data, and then you could do like a sync and look at it, right? So that's the best practice is like, all right, I'm going to deploy my smart contract. Here's it on GitHub. Here's it on Etherscan. This is my wall of truth. I can be trusted, right? In that sense. Compiled. Bytecode, yeah. Yeah, it's humanly unreadable. So the concept is here, we've submitted our source code to them, and the ABI is being generated essentially, so we're able to see all of our functions. here, send message, set greeting, and withdraw. Same thing goes with Scaffold-ETH. We're injecting the ABI into here so that we know how to interact with our smart contract because it's in bytecode. There's also a really cool tool called abi.ninja. You can put any contract address in here. Like if I was to paste this one, where'd it go? If I was to take this, you could paste it in here like this and say load contract. Oh, switch to mainnet. Oh, sorry, one second. Oh, it doesn't work on Spolia. Really? Okay. Anyways, if there was a contract here, you could interact with it, and it will load the ABI. If you didn't have the ABI, you could also paste it in here. So there's some cool tooling in there that you can mess with it. But you can think of the ABI as like this map to your functions, right, of the actual application. Follow-up question? Yeah, thank you so much. Okay. Any other questions? I just another hand. No? Yeah, we can talk afterwards. I'll hang. And thank you guys for coming. Really appreciate it. Thank you guys.